Look at this. My name's on the phone.
Okay, so yeah, I'm recording this instead of making a review video. This is just going to be up there.
Wait, you're recording this right now?
Yes, sir. Alright, let's get started. And if you did not have class today, we went over quickly what is going to be covered, so you'll address that in period 4, period 6. So this packet is just a review of some questions that I think will help you for the test. So first page is really just definitions. This is really the first thing we covered, and I typed them up so you don't have to write anything. But just a quick review of corresponding sides. So have the same relative position. So BA, JH, for example. Corresponding angles, again, have the same relative position. And in a similar figure, the corresponding angles are equal and the sides are in constant ratio. So we need to know that in order to even do what we've been doing with similar triangles. So, all right, and then again, we should be okay on scale factor, but quick review, always multiplication, right? Never division, small to big, greater than 1 or less than 1. Greater. So if we go from small to big, it has to be greater than 1 because we're increasing the size of the numbers. And then the opposite, big to small, will be the reciprocal, and that will be less than 1. So if you're finding these scale factors on your test, you can keep that in mind as a check. Is it less than 1? Is it greater than 1? Is it reciprocal of the other one? Okay, so this came, what, yes, 2 days ago, so not exactly in order, but cross multiplication. I just want to review the algorithm because when we're setting up these similar figures, we know that we can find scale factors or we can set up ratios and cross multiply. Yeah, question?
One thing I was confused, wouldn't you switch the A with the X? So, the X would be where the A is, so what would you do for that?
If the X was where the A was, you would still multiply on the diagonals and then set them equal. So if X was over here, it would be X times C equals B times A. So you set it up by looking at the figure, right? Or by reading the word problem, or whichever quantities are relating to quantities. So the algorithm is, and I left you a spot to write this if you want, multiply on the diagonals, set them equal, and then solve for X. So in a situation like this, we know that we divide by B to get X. So that's really how you cross multiply it. Algorithm works every time. Multiply the diagonals, set them equal, and solve for X. Anyone confused on how you cross multiply? Okay, so getting into solving some problems. We know that these two figures are similar. So because we know that they're similar, we can find the missing sides by using the scale factor and the proportions. So can we take a look? Does someone think they know the scale factor from the small figure to the large figure? David? 9. So if we take a look, 9 times 10 is 90. 4 times 9 is 36. Okay, so if small to big is 9, what's a big to small? Maddie or Meredith? I'm sorry, which one? Maddie? Right, it's the reciprocal. And again, check. Small to big, we're increasing. This is greater than 1, so that makes sense. Big to small, we're decreasing. This is less than 1, so that makes sense. So given the scale factors, we would do X equals 10 times our scale factor. Or I'm sorry, not 10. 7, because it's the corresponding side. So 7 times our scale factor gives us X, which is 7 times 9. Lexi? Right. And then for Y, we would do what? Can somebody tell me how we would find Y using the scale factor? Ishi.
You divide 126 by 9, or
You do divide 126 by 9. When we're talking about in relation to scale factors, we just say multiply by 1/9. And that gives us 14. Okay? But we also know that we can do proportions. So this scale factor was a whole number, so it was pretty simple. But if it's not, we can set up proportions. So, who thinks they could give us a proportion? Jack?
36 to 126 and 4 to y.
36 over 126
Sorry.
equals 4 to y. So, this side to this side in one figure. So we need to make sure that these two sides correspond with these two sides, which they do. And if you solve that, you would get 126 times 4, divide that by 36, and it'll be 14. And you can do other proportions too. So for y, I could do, what? You can tell me another one for y. Lauren?
36 over 4 equals 126 over 1.
Right, so now I'm going this way, so 36 to 4 corresponding sides, and then I have 126 to y. And again, look, if you look too, the cross multiplication gives you the same equation, which gives you the same answer for y. And likewise, we can set our proportions for x, so he can just give us one proportion for x. Sammy?
X over 7
Okay.
equals 90 to 10.
Right, so if you start with the triangle on the left and relate it to the triangle on the right, you have to start with the one on the left and relate it to the one on the right. And when you solve that, you'll get 63. All right, any questions on these ones? So here's another one. So if you take a look, you're just given these two triangles. And then we want to find x and y and s and t. So s, t, and y are angles and x is a side. So the first thing I did is that I rewrote them so they're kind of facing the same way, corresponding sides to corresponding sides. I just think it's easier. And one way we know how to do that is if we look, we know this angle is the same. And what is the degree of this angle? Right, so this bar means 90 degrees. So I did it that way. Put the hypotenuse on the right and set it up that way. So if this is 90 degrees and this is 42 degrees, does somebody know how to find or what the value of y would be? Luke.
Well, in total, it has to be 180.
Okay.
So you add 42 and 90, and then that has to be subtracted by 180.
So 180, and you said add 42 and 90. And what do you get when you do that?
That's 48.
Right, so this will be 48 degrees. So now we have 90, we have 42, and we have 48. So what can we say about T and S? So these triangles are similar. We figure out all these ones. What is T? So let's think about the definition of similar figures. What has to be true about the angles?
We'll have to add up to 180.
So if two triangles are similar, I think I heard it, they're all the same. So if we go back to our definition of similar figures, corresponding angles of equal measure. So knowing that, T has to be the same as which one?
Y.
So corresponding angles have to be equal. So we set this up so the angles match. So you just look and see that T corresponds to, 42. S corresponds to Y, which is 40. Okay, so now we want to find X. So we already found the angles. Question?
No.
Okay, so we found the angles. Let's find a scale factor. Who can tell me the scale factor from the big one to the small one? Meredith. So big to small, yeah. Because 22 times 1/2 gives you 11. So then we automatically know that small to big is 2. Yeah, it's a reciprocal. Okay. So given the scale factors,
Wait, if you write 2 over 1, do you care if you write 2 over 1 or just plain 2?
you can write 2 over 1, but it's not simplified. You know what I mean? So technically
that's
the simple.
the point.
I do not know this. You should write 2.
Lauren, just write this.
Okay.
Okay, so knowing our scale factors, you can tell us what x is. So we know that AB corresponds to sine DE, and we know our scale factors. So how can we figure out x? Ethan. So you don't divide 16 by 1/2. You multiply 16 by 1/2, and you get that x is 8. Okay? And we can also do proportions. And we know multiple ones, or multiple ways, but who can tell us one way to set up a proportion for x?
Arda.
What?
Yeah, do it.
Sammy.
So
Yeah, alright,
x
come here.
over
Stop taking
16
phone calls, man. Come on.
and then equals 11 over 22.
So if you take a look at this here, x to 16 corresponding sides, that's this ratio. And then 11 to 22, another ratio of corresponding sides which have to be equal. And when you multiply and solve this, you will get 8. And again, there's other ways. We're just going to do one.
Okay.
Any questions?
Okay. Yeah.
All right, one more. So the figures are similar, and we want to find both scale factors and the value of x, and we'll set up a proportion. So this one, scale factor, not going to be a whole number. So who can tell us what they think the scale factor is? So from small to big, in other words, what do I multiply this by to get this? Give me a. Okay, so 1.25 is correct, or I like to write it as fractions just because it's easier to flip around for the next one. So 1.25 is equivalent to 5 over 4, and then we know that big to small is what? 4/5. Okay. So given that, can somebody tell us the value of x? Meredith? 6. So it'll be 7.5 times, we're going big to small, so 4 over 5, which gives you 6. And an example of a proportion, so I could relate these two sides, so 7.5 to x equals 4 to 3.2. That's one example. Does anyone want to give us one more example of a proportion? Jack?
4 over 2.2 and 7.5 over x.
4 over 3.2 equals 7.5 over x. Okay. So there's an example. Another one. Okay, before we move on, any questions about cross multiplying or scale factors, finding sides, finding angles, what it means to be a similar figure? Sammy?
It's not really a question, but I just want to say I really like cross multiplying.
I'm happy to hear that because you didn't like it at first
You
yesterday.
hated it yesterday.
Yeah, it's great. I love it. I'm a big fan. Okay, so we all love cross multiplying, I hope. Alright, let's move on. So, if you flip to the next page, I put the definition and a ratio up there. So, who would like to read our definition? Alina.
A ratio is a comparison between 2 or more objectives that indicates a constant relationship.
Yeah, 2 or more objects that indicates a constant relationship between them, and we worked with those just in our similar figures, and we'll work with them in word problems and stuff too. So this is from the packet actually. So 1, 2, 3, 4. That was when we were comparing Border Cola and Cola Nola. So we talked about this, how number 1 is kind of like, we can describe it as a total statement. 2 is like a difference. It's like 5,713 more people. 60% goes with percentage. 3 to 2 like a ratio. And then we talked about some advantages and disadvantages. So who can tell me an advantage for a total?
Oh, you know,
Allison.
it gives you like the actual numbers if you like wanna like keep, if you wanna like write it down the real thing.
And it gives you a lot of information. We can figure out the total, obviously, and we have the 2 parts as well. What about a disadvantage? Yeah.
If you're looking at it quickly, you're not going to want to read like a big number.
Yeah, it's a lot of information which can be good, but if you're looking at it quickly, it's like too much. Do I want to read all that? I don't know, maybe not. What about a difference? You can tell me a advantage, disadvantage, whatever you want about a difference. Arda?
Yeah.
Okay.
It's too little.
What do you mean by too little?
I mean, like the opposite of one for it.
Sorry, what?
Like, there's not many numbers you have to look at, so it's not as hectic.
So, it's less hectic. Okay, just one number. You can tell me something bad about a difference.
colors.
Camia?
You don't know how many people were surveyed.
Exactly. You have no clue how many people they asked. It could have been 5,714. You know. So, keep in mind that. Percentage.
How good of a review session is. People want to take pictures so we can capture it.
What?
I just want everybody to know I really like crosswalk. Don't see it when we're under attack. You yell at her. Alright, get back to that.
So, a percentage we talked about we liked because, you know, they're universal, and for here, it shows the majority. So if I tell you that 60% of some people like this, well, you know that more than half of it. And then a ratio, small numbers.
What the heck?
Outside.
Don't worry about it.
They're
Okay,
hole.
so besides the distractions, any questions about these?
Our new group is going to spark one.
Oh, okay, so, suppose you surveyed 1,000 cola drinkers. Using this information, what can we assume about a sample size of 1,000? So, what can we predict about 1,000 people? So, how many do we think will like Border Cola and Cola Nola, and why? So, okay, let's hear it.
Okay, 600 people will like Cola Cola, and 400 will like Cola Nola because in the ratio it says 60% prefer Cola Cola and 60% of.
So the ratio doesn't say 60%. I mean, you can get to
The
60%, but yeah. Okay, so the percentage is 60, and we know that 60% of 1,000 is 600, and then we have 400 left over for Cola Nola. What if we try to use the ratio? So what is it, 3 to 2?
Mm-hmm.
So given 3 to 2, how can we relate that to 1,000? Allison.
So like just take away the 0 and it's times 2. Like 3 times 2 equals 6. 2 times 2
3
equals
times 2 equals 6. That is true, but I'm not exactly sure what you're saying.
like you can like take it and like so it goes into the numbers.
So I think what you mean is that if you add a 0 to each one, so 30 to 20, and then you multiply them each by 2, so then it would be 60 to 40, and that would be.
Okay, I see what you're saying. You were scaling up the ratio?
Yeah.
Okay. So yes, we can scale up the ratio to get 60 to 40. We can scale it up even more to get 600 to 400. So that is correct. Another way is we can think about part to whole. So just to show you, if we have 3 Border Colas to how many total? Right, so this would be 5 total. 3/5, we could do 3/5 times 100. We can get 60% from 3/5. So you have a lot of different options. Yes?
Well, this didn't use the, like, that method, but, like, I used the same numbers, because I did, to find out, I did 1,000 divided by, like, the total of the ratio, which is 5, and then I did that times, like, the 3 and then the 3.
1,000 divided by 5.
That's 200, then you do 200 times 3, that's 100, and 200.
So you split 1,000 into 5 parts, and then you know that 2 of the parts have to be cool and null, and 3 of the parts have to be.
Yeah.
Okay, yeah, you can do that as well.
Okay, so
Many different ways. Okay, so we're not going to do a statement for all of these. I'm not going to write any down. I just want you guys to think about it. So if you have this table here and it was advertising spending on different, I guess, types of advertisement in 2000 and 2010. So if I ask you to write a part-to-part ratio or statement using a part-to-part ratio, let's say for 2010, you can give us an example of one thing you can say in red. Jack?
That 18,203 people of
Let's do, this is 2010. Okay, we'll do 2010.
oh, okay.
So 18,203 people.
To 7,728 magazines.
So you'd have to say something about that. So what could you say? If you give me that part-to-part ratio, what would you say?
Out of every 18. Oh, okay.
Wait, what's this?
7,728.
You could say that out of every 18,203 people, 7,720 people like magazines.
So is that out of 18,203 people?
No, with like for every 18,203 people who get the newspapers, 7,728 get magazines.
So this is the amount of money spent. So when you're doing something like this, you have to look at the information you're given. So it's not get newspapers, it's how much like companies spend on advertising. So you could say for every $18,203 spent on newspapers in 2010, they spent 7,728 on magazines. Okay? So make sure you know what information you're given, how you can not only write a ratio, but translate that into a word sentence. Who can give us a ratio for part to whole? Tell us if it's 2000 or 2010 and follow it up with a sentence. So part to whole. Arda?
2010 and 18,203 newspapers to 109,645.
So that is a part to whole ratio. We have newspapers, we have totals. What could you say about that ratio though? What does that mean?
It's newspapers to everything.
So if I asked you to write one word sentence for us, what would you say?
That's how many newspapers made in 2010 compared to all placements in that. I don't know.
So we have to make sure we know what information we're given, right? What are they giving us in the table? So it's not making newspapers. It's how much is spent on advertising.
Yeah.
Okay, so who can give us another summary of this one? Kaylee?
Out of all the money spent on advertising, newspapers took up $18,203 of it.
Okay, yeah, so in 2010, out of all of this money, so $109,645 spent on advertising, newspapers took up $18,203 of it. So, do you guys see how we're picking out part-to-part ratios, part-to-whole ratios, whatever they're asking for us, and then we can relate that to a sentence? Yeah. Yes. There you are. So, I'm not going to go through all of these, But, so make sure you can do this for a fraction, a difference, and a percent. Would there be any, does anyone not know how to do this for a fraction, a difference, or percent, or would like to see one? Which one do you want to see?
Fraction.
Alright, let's do fraction. Who can give us a fraction?
Oh, no, don't call him Doug. Don't call him Doug.
I don't know who Doug is.
That's Doug. Don't call
Maddie.
him.
So in 2004, 4,984 over 91.
4,984 over what?
95,441.
95,441. So this looks like this is total spending. This looks like this is yellow pages. Okay, so there's a fraction. How could we say something about that? Or what would we say about that? Okay, I've made that worse. So 4,984 over 95,441. So we need a statement about that. Yeah, go ahead.
In 2004, $4,984 was spent on newspaper over on yellow page to minus 95,441.
Yeah, so Ethan, this is our fraction. We picked yellow pages over total. And if you look, the specific fraction we picked was kind of like a part to whole ratio. So pick your comparison, be able to talk about it. Any questions? I'm going to move on to some other ones. Yeah?
Never mind.
Yeah? Difference. Who can tell us what difference would mean? Kaylee?
Wouldn't it be like the difference from like 2000 to 2010?
So I want either 2000 or 2010. So
Okay.
let's look at this. What did they do for a difference?
Oh, they did the difference of the two.
So let's think about this. In a taste test, 5,713 more people preferred Florida Cola. How could we use something like that as an example to write a difference? Allison?
You could do it like in like the same year, but with like two different things. Like you could compare newspapers and magazines, or
Yeah, so if we compare newspapers and magazines, we would find this difference, say it's X, and then we could say in 2010, X more dollars were spent on advertising in newspapers over magazines.
Or you could do the total.
Yes. Ainsley?
Okay, for 2010, could I do the total and then subtract the total of newspapers and then get my answer and say dollars not spent on newspaper?
Yeah? So there's a lot of variety here. Sammy?
So for the difference, I'm like a little bit confused on it. Would you just do 2010 minus 2000?
You could do that, but that's not what's being asked here. You know what I mean? So you can find whatever difference you want. If they just said find a difference, but this says for both 2000 separately and then 2010. So if you wanted, if they said compare 2000 2010, absolutely, that's what you would have
Yeah,
to.
it is really important. If they say in 2010, you better stick to the right side of the column. That matters.
So then you
If they say
could
2000, use the left. If they ask you to compare the years, that'd be a huge issue.
you could do television minus magazines.
In either year, yeah. Just if you're doing 2000, you would use 19,318 and 4,973.
What?
If you're using 2000. But if you're using in 2010, 35,718 and 7,728.
So stick to what they're asking you. If they want a statement about 2000, stick to 2000. If they want a statement about 2010, stick to 2010. If they ask you to compare across years, then that's what you would do what you're talking about, Sammy.
Oh, so like
Again. Wait.
Yes, Laura.
Okay. So if they were asking about 2000 and 2010, could you do the totals and say the difference between total spending in 2000 and 2010 is like amount of dollars?
If they ask you to compare the 2 years, yeah, it all depends on what the question asks.
But no. But if it asks you to compare the 2 years like together, do you have to choose like a specific of like newspapers, or can I do the total?
It would depend on the question, but if they just said compare, write me a statement about the 2 years. Compare the 2 years. If they say compare the totals, you would compare the totals. If they ask you to compare a specific thing, you know. So it all depends on what the question's asking you. So you have to read the question, you have to make sure you know what information you have in the table, and then go from there. So, any other questions on picking information out of the table, writing comparisons? Arda?
Can I go to the bathroom?
Sure. Sammy?
Can you like demonstrate a percent?
So, let's take this fraction that we already have. I would divide that, get a decimal, multiply it by 100, and that's my percent. So, this was Yellow Pages, the total in 2000. So, I would say in 2000, whatever this percent is of the total spent on advertising was spent on Yellow Pages.
Yeah, Doug.
Good discussion. Any other questions? Alright, so making lemonade. So, here's some mixes, A, B, C, and D, and we know there's a whole bunch of ways. On the packet, I just put room for 6 specific ones. So why don't you guys look at the 6 and tell me which ones you would like to see. So we have part to whole. We have 2 different part to wholes. We have 2 different part to parts. We have common numerators and common denominators. So is there any specifically that we would like to see?
Can we do them all?
We can, yes, but then we will. That would probably be the last thing we do. So, it's up to you guys. We could do all of these, or we could do a couple and move on to proportions, and then there's a couple more problems on the back with proportions.
Let's do all of these.
I think we should try and cover everything.
Let's take a vote. Who wants to do every way of lemonade? Okay. So if we don't want to do every way,
No one
that's.
wants to be like Lauren.
If we don't want to do every way, that's fine. But let's pick one way we want to see. Or if you guys don't want to see any at all, we can move on to other parts of the packet.
Strangled me this morning. Concentrate.
All right, so we're doing percent concentrate and percent water. So that would be part to whole. Because, do you mean out of the entire solution? Which ones do you mean? Okay, percent concentrate. So for A, if I want percent concentrate, I have to have a part to whole. So for A, let's say 4 concentrate, and remember labels, over, 9 water.
Total. It's 80%.
Or 9 total, thank you. And when you do that, you get about 44.44%. And that would mean that A, that lemonade, is 44.44% concentrate. Ethan.
I just have a question.
Yes.
Oh, not calculators.
You're gonna have yellow calculators. Alright, so B, for example, it would be 5 concentrate out of 11 total. And when you divide that and multiply through by 100, you would get 45.45%.
Would it be 5 concentrate of 9 because it's part to whole?
So 5 plus 6 for on B. Yeah. So 5 concentrate over 11 total gives us 45.45%, and that's percent concentrate because we're comparing concentrate to total. If we wanted to do C, it would be 3 concentrate over how much total? 8 total. And if you divide those and multiply through, you get 37.5%, and again, that would be percent concentrate. And finally, if we would do D,
Wait, we are doing them all?
it would be 6 concentrate over 15 total. Divide that, multiply by 100 to get 40% concentrate. So, this is percent concentrate, so you compare concentrate to the total juice, lemonade, whatever. So, looking at this, what's the most and what's the least in order? So, most to least.
B, then yeah, mix B.
Melena?
B, A, B, C.
B is the most, A, then D, then C.
So it's back.
Bads. Okay, so now this is percent concentrate, so we pick the highest percentage, B, A, D, C. So if we were to do percent water, would we pick the highest percentage or the lowest percentage, and why? David?
Lowest percentage of water.
Right, so if you do percent water instead of percent concentrate, and for example, that would be 5/9, right? Because now we're comparing water to the total, so that will give us percent water. We want to pick the least water, or the least percentage, because least watery means most juicy. So this one here on the board is percent concentrate if we flipped and compared water to total. So what, 5 to 9, 6 to 11, 5 to 8, and 9 to 15. That would give you percent water, and you can pick the smallest percentage. Would you like to see part 2 part or common denominator, numerators or denominators?
Common numerator.
Common numerators? Okay. So if we have A and let's say it's 4 concentrate to 5 water, and we have B, 5 concentrate to 6 water, and right now I'm just writing part to part ratios. C, 3 concentrate to 5 water, and D, 6 concentrate to 9 water. Okay, so I want a common numerator. So 4, 3, 5, and 6. We want to pick a number that is divisible by 3, 4, 5, and 6. So you can pick the least. You can pick any one really. So what do we think?
Bless you.
Okay, I'll tell you that I use 180 because 180 is divisible by 3, 4, 5, and 6. So once you find out which number is divisible, you write it as your numerator. So for all of these, our new fraction has 180 cups of concentrate in it. So now I need to find a denominator. So if A, the new numerator is 180, how do we get the new denominator?
You multiply by 9.
Lexi?
Multiply, or you divide 180 by 4.
And you get,
45.
okay, so then what?
Then you multiply 5 by 4.
Right. And then 5 by 45 is? And that's 225 water. Okay? So let's continue on. B. How do we get the denominator?
180 divided by 5.
Same way, divide 180 by 5.
We didn't have to go for
Yeah, thank you. You're welcome.
Is that the same packet?
it.
I don't know.